So here we go again. We've restarted the system, and let's explain the user interface screen here. On the left hand side you see five different icons. First one is trigger, second one is untrigger, third one erase, fourth one is mode, and fifth one is config, which is the configuration of the system. So these are the controls that we have, and on the top right hand side is the actual reading window where the OSE reading will be shown, and right below the OSCE you will see the current selected mode. This system has two modes, real-time mode and peak detect mode, and right now the system is in real-time mode. So if a reading is taken, it shows and then it goes away. Whereas in peak detect mode, it captures the peak reading and keeps it in the OSCE reading window until the next reading is taken. Right below that you will see three information windows: out low, sample not grounded, and range OK. Out low refers to the fact that the reading that is currently shown there on the OSCE meter is below the lower limit or higher than upper limit, so it's outside the limits that have been set up, and we'll go over that in a little while. Sample not grounded shows that we did not connect the grounding cable from the rear of the unit to a grounding plane. So once that's connected, this will show sample ground OK. Range OK usually refers to the sensor gain and panel gain. As long as the maximum reading stays below 1000, then the range will be OK. If the reading goes above 1000, then the range will not be OK. Then the sensor gain or panel gain will have to be changed to bring the gain into the range. Right below there you have several small windows. First one is threshold. This is a reading that is used in peak detect mode, and we'll talk about this a little bit more when we discuss peak detect mode. The number of readings shows the number of readings that are in this current file. One thing this new system has is that it creates a file, and the file name is shown here, and the file name is automatically assigned by the computer. Basically it's the date and the time that the system was started. It uses that as a file name to create a file, and every time there's a reading that is taken, and it will be automatically, the reading has to be taken in the peak mode. In real-time mode there is no reading that is saved, so whatever you see in real time is what it is. There's no record of it. In the peak mode, once you start taking readings in the peak mode, then it will keep track of the number of readings that are in the current file. So this file is on the hard disk of the system and can be accessed, and since it's a text file, it can be imported into Excel, and data can be analyzed or manipulated in whichever way the user wants. Right below we have a setup of the upper limit and lower limit. The upper and lower limits are set to sort of set an acceptance range. So if the reading is within these two limits, then the reading will say OK, and it will also show green in the background. And if the reading is outside these two limits, either lower than 300 or higher than 800, then out low or out high will show, and the background in the window will turn red like we see right now. On the right hand side is the information about the setup for a particular part inspection. For each part we have to select the best panel gain, sensor gain, and record that information for future purposes, because if we do not record that information, Next time we want to test the same part, we may not be able to compare apples to apples. And gain setting is something that is selected based on, so that on the cleanest part, the combination of the panel gain and the sensor gain does not give a reading higher than 1000. So if the reading is less than 1000, that's the gain setting is then correct. Right below you have sensor size. This sensor size usually refers to the opening of the sensor. What we're seeing here is not a correct record. We will change that and put down the actual size, which happens to be right now a 1/4 inch aperture, and we'll show later as to how to set that up. Sensor gap refers to the distance between the sensor and the sample surface. That distance has to be maintained. The sensor can be in contact with the sample that we're testing, but if we do not want to contact the sample, then this distance between the sensor, end of the sensor, and the sample surface has to be consistent and constant. So there's a sensor stand provided for that purposes, and the sensor can be mounted in a sensor stand in such a way that the part can be put under the sensor without actually being in contact with the sensor. So right below, as I mentioned earlier, this is a file name. So today,